This video will give you a head start, a little bit of idea, and with that, when you come to the classes to watch, when you come to the classes to study, there things will be much more clearer to you. Okay, and about this periodic classification chapter, it was there actually in your grade 9th, and here we are just continuing that topic right now. Okay, yeah. So the main thing about this chapter is mainly to talk about the the conceptual part. There is no numericals that will come from here, so that's a relief, I believe, for many of the students, because the first and the second chapter was all numericals there. Now the third chapter, the first part of this chapter is completely based on the the history of periodic table, which we can skip very easily, or you can just give it a reading. It's like nothing important in it. Sometimes they do ask you what is eka aluminium and what is eka silicon. Okay, so yeah, that's it. Like, just give it a little bit of reading, like what is what and all. So like, there is nothing much to talk about there. The real part of the chapter starts from here actually. So this talks about the nomenclature part. Okay, so how to give a name to a particular compound. So generally, every single compound has a particular name given to him, and it's based on the one who has actually discovered that compound. But that way, it was getting very difficult for the rest of the scientific world to remember all the elements out there. For example, there are elements called mendelevium, europium, then californium, rutherfordium, right, curium. So these are the kind of berkeleyium. These are the kind of the elements which are there based on those scientists actually. So we are trying to find a way out, and IUPAC, they came up with a nomenclature method, which the goal went like, whenever you have one, that means you're gonna call it un, two you're gonna call it bi, zero you're gonna call it nil, just basic things. So in this way, 1 2 3, 3 you're gonna call it tri, 4 you're gonna call it tetra, like that. Okay, just goes on like that. In this, 5 is pent, 6 is hex, just the normal way. Okay, 7 is sept, 8 is oct, 9 9 over here. There's only one different over here. So 9 means not known, which is actually the IUPAC of organic compounds. 9 means known, so nonane, right? We should do here. 9 is called N, E-double-N, N, or single N. So N is actually 9. So that is the only thing that changes. So let's say we have an element which is 109. What am I gonna call it? 1 means un, 0 means nil, and 9 means ennium. That's the name of the compound, and the symbol for this compound would be U-N-E, just the first letter of every single segment. So if I have an element, you give it a try. If I have an element which is 106, what are you gonna call it? Un, nil, hexium. Correct? So that's the way, guys, they have actually made the nomenclature, which you can see completely in this part of the table. You can see that these are the nomenclatures and these are the names. Okay, like 103 is unyl trium. Correct? Unyl trium. 103, sorry. 104 unyl quadium or tritium, same thing, quadium. Unyl hexium, unyl septium. Correct? So it just goes on like that. The real name given to them was mendelevium, nobelium, lawrencium, rutherfordium, but right now we apply this method to remember the names. Okay, from 101 onwards. So right now, if an element gets formed, let's say right now the last element we have found, artificial one, is 118. So we are going to call it unoctium. Correct? UUO is the last element found so far. Okay, so you can see that UUO, unoctium. Alright, so this was the first part of the video. Now we'll be moving on to the next thing. I believe this was very simple for you to understand. Organism was the last element. Now the next part of the video, we are going to talk about the configuration, electronic configuration. Now that you have learned already from the last chapter, where we have actually talked about how to do the electronic configuration of all the atoms. So jump into that. So about the electronic configuration part, mainly what you have to do is, there are in the periodic table, there are some blocks that they have divided the entire periodic table into. So as you know, periodic table looks like this, and if I talk about the groups, group 1 and group 2 stays in the left hand side of the periodic table. From there, group 3 to group 12 is in the middle, and then 13 to 18 is on the right hand side. Group 1 and group 2 are called S block element. Group 3 to 12 are called D block element, and 13 to 18 are called P block element. Now the reason behind calling them such a way is based on the last electron. So where does the last electron enter? Based on that, we talk about the block of the atom. Let's talk about an example. We have a sodium. Sodium's atomic number is 11. So how would you write down the electronic configuration from the atomic structure we learned? 1s2, 2s2, 2p6, 3s1. Now the last electron has gone into S subshell, right? So as a result, it is an S block element. Okay, let's try another one. Let's say I have carbon 6. Now pause the video and you try it once on your own. 1s2, 2s2, 2p2. So where is the last electron going again? P subshell. So it is P block. Let's try another one. Let's say we have iron. Iron is 26. The electronic configuration goes like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. You know, 4s comes before 3d energetically. So this is going to be your order. Now, if you notice, the last electron, it's actually going into 4s. So you might be thinking that it is a S block element. But if you notice, guys, the 4s may be the highest energy shell, but the last electron is actually going into 3d subshell. So if I ask you what is the next element, let's say from iron, we have nickel, 28. For 28, what is the electronic configuration? The entire thing will remain the same till 4s2. So let's like write 1s2 to 3p6. It will remain the same. Now after that, you will be writing 4s2, 3d8. So the electrons, if you notice, it was 6, now it is 8. So that means the electrons are going into 3d subshell, not the 4s. Although 4 is the higher shell, but we know that from the rules, N plus L rule, 4s has lower energy. Although it is 4, but it has lower energy than 3d. So considering that, it's a D block element. All right. So these are D block element, because the last electron is going into the D subshell. So simply, guys, in this way we can easily find out the shell, the electronic configuration, and from there we can find out the block of an element. Now, if I talk about S block elements, so there what actually happens is, for S block elements, the general electronic configuration goes like NS2, NS1 to 2 actually. What am I learning right now? General electronic configuration. General electronic configuration goes like NS1 to 2. For P block element, the general electronic configuration goes like NS2, NP, 1 to 6. Now what do I mean by this? That means, you know, group 1 and group 2 are called S block element. So if I take an element of group 1, let's say sodium, you have seen that it ends with 3s1. So it comes under NS1. And if I take someone from group 2, like beryllium, you will be able to see beryllium is 4. So 1s2, 2s2 is the electronic configuration. So it got the NS2 configuration. So either it will be NS1 if it is group 1 element, and it will be NS2 electronic configuration if it is group 2 element. That means, guys, in a way you are getting a hint right now based on how many electrons you have on the top, that tells you which group you are from, isn't it? So exactly, guys, you got it right. Let's say we got an element called carbon. Carbon's atomic number is 6. So let's say it is 1s2, 2s2, 2p2. Right. Now, guys, it is definitely a P block element. Now, if you notice, it is in the electrons present in the last shell is 2. That means it is the second period, second group of P block. It is in the second group of p block. Okay, now p block starts from where? P block starts from 12, 13 actually. 2 to 12 is your d block element. P block starts from 13. So where is carbon then? Carbon is the second group of p block. So 13 is the first group, 14th is the second group. So carbon is in the group 14. So that means if I try to find out where carbon is, all I have to do is I have to search in the group 14 of p block. So let's see whether carbon is present in the group 14 or not. So we are gonna go to the periodic table that they have given to us, the modern one, and we are gonna see group 14, and there we are gonna find carbon right there. Okay, so this is the way we can also find out the elements, but that's not the point right now. My point is, if you are a p block element, then you can have either p1 or p6. In this range you will be having ns to np1 to ns to np6. That will be your range of p block. If I go for d block, similarly the general electronic configuration is always ns2 n-1 d1 to 10. Now why is that? Again, if you look into iron's electronic configuration that we have just done a minute ago, it was 4s2, the last two shell I'm writing, 3d6. So from there you can clearly see, if I consider 3d as n minus, 4s as n, so 3 is n minus 1. So ns2 n minus 1 d6. That's the way we find out the electronic configuration of d block. Now it can be 1 to 10 because that's the capacity, right? D can have up to 10 electrons. So that's why we are going for from 1 electron to 10 electron. Anything can happen here. If I go for F block element, now here the things are going to be a little bit more intense. Here it goes like ns2 n minus 1 d1 to 1 to 2 and n minus 2 f1 to 14. Now you can clearly understand, guys, F block has total 14 electrons it can accommodate. So as a result, we are going for 1 to 14. Now why is ns2 n minus 1 n minus 2? Why is it like that? So it is the way the electronic configuration, if you try to follow an electronic configuration of F block, how will it look like? So let's talk about cerium. So cerium's electronic configuration goes like xenon's electronic configuration followed by so you can go for 4f, 4f1, 5d1, 6s2. This is how the electronic configuration looks like. So you can clearly see that here n, if I consider this to be n, then this will be n minus 1 and this will be n minus 2. So all the shells are there, present in there, and guys, these all three shells act like a valence shell. Now what is the valence shell? The outermost shell is called a valence shell. Now all I'm saying is 4f, 5d and 6s are having almost equal energy. This is according to the Bohr's correspondence principle, which tells you more you go to the higher energy level, the discreteness of the energy levels are not there anymore. They kind of come very close to each other. So as a result, guys, what we can do is more we go up. So if you notice, for S block, I have given only one valence shell, which is ns2. When we move to P block, you can see two valence shell I have drawn, ns and np. For D block also, ns and nd, two valence shell. Here you can see three valence shell. So actually what happens is they are very close to each other. Energetically they are very close to each other. That's why we have to draw all three of them. So this is a basic level of electronic configuration which is there. Now guys, we'll be moving on to the next part. According to the book, I believe we have the general electronic configuration that we have just covered up. Okay. So we're going to stick to the NCERT because of their exam preparation purposes. We are learning this. Okay. So after they have completed the electronic configuration, yes, then they have moved on. The element 117 has not yet discovered, which is family. Okay. Alright, so now the periodic properties of trends in the physical property. Okay, now the trends comes. But before the trends comes, I'm gonna just tell you about another physical thing over here. physical method which we rather say. So here guys, give the heading of how to find the position of an element in the periodic table. Let's say guys, I have given you a question like I have an element whose atomic number is X, the atom is X, and the atomic number is given as, let's say, 2. I want you to tell me where does it stay, like in which period, which group. So guys, as you know, in the periodic table, generally the vertical lines, the vertical lines are called the groups. So group 1, group 2, group 3, so they are called the groups. And what is the period? Period is the horizontal lines. So if you have seen that the periodic table is broken like this, divided like this. So these are period. This is period 1. This is period 2. This is period 3. In this way, total, how many groups do I have? I have total 1 to 18 groups. How many periods do I have? We have 1 to 7 periods. Total 7 periods and 18 groups is what I have. Okay. Now, let's say I want to find out from where is it coming and all. So for that, what we can do is so for this X element, which is atomic number 2, what we do first is we write down the electronic configuration, which is 1s2. Now, the highest energy that comes, 1. Here is only one orbital, the outermost orbital is 1 only. So whatever is the outermost orbital, that is your group number. So guys, where would I find this element? I will find this element in group number 1. Okay. Now, if I take the next part, which is S, that tells you it is an S block element. And 2 tells you, I'm very sorry, 1 is the period. So it is going to found in the period 1. So somewhere in this line. S means it's an S block element and 2 is the group number. So X, its atomic number is 2, can be found in the first period S block second group. Let's try it again. Let's say we have an atom which is, let's keep the identity of the atom X. Now, if I take the atomic number of this atom as, let's consider, 12, okay? An atom has atomic number 12. So how will you go for the electronic configuration? Then definitely 1s2, 2s2, 2p6, 3s2. Now in this electronic configuration, the highest energy is 3. That means it is in the period 3. Okay, so it's in the third period. Now, this is an S block element and in group number 2. That's how we find out. Okay, let's try again. Let's say I have an atom which is X and having atomic number 11. So it will go like 1s2, 2s2, 2p6, 3s1. Now again, it's an S block element, we can clearly see. When it is S block element, things are much more easier for you. So we have found out this S block element. And which group again? Group number 1 and period number 3. So that means I will find it somewhere in the third period, 1, 2, 3, third period, group number 1. This is where I'm going to find it, this element. Okay, group number 1 and S block. It's already in the S block, all right? So this is where this element is actually. So if you just check that part, you'll be able to see that is sodium. Sodium is present in that part of the periodic table only. Now, whenever you have noticed that I have taken only the S block element example. Every single time it was S block. So for S block element, it is very easy to find out the electronic configuration, and from there it is very easy to find out the position of the element. But let's say the element is a P block element. In that case, how do we find out the position? So let's say we have an element of atomic number 6. So what is the electronic configuration then? 1s2, 2s2, 2p, 2. Now according to what I taught you so far, you will go like period is equals to 2. Block is not S this time, it is P, and group will be going for 2. But the next question should come in your mind is that, sir, in group 2, if I talk about group 1 and 2, you have just taught us that group 1 and 2 is S block. So how can the group be 2 for a P block element? So exactly, you got it right. So it's for the P block element, what you have to do is you have to always add 10 with it. Why 10 with it? Just because we want to skip these 10 elements in between. 3 to 12 is actually your D block element. So that's why you have to add 10 with it. So moral of the story is, to find out the group of P block, you have to add 10 with it. So 2 is the number came in. So 10 plus 2 is 12. So this element is present in group number. Okay, there is one mistake that I've done. Wait a second. So period is 2. Block is P. So far it's fine. Now if you notice, the total number of electron in this shell, the total number of electrons. So what is the group telling us? How do I find out the group again? From the total electrons present in the shell, not the subshell. If you notice, the shell is 2, subshell is S and P, but the shell is 2. How many electrons are totally present in the shell number 2? Total it is 4. 2s and 2p combined together it is 4, right? So I have to take that number. So 10 plus 4, it is 14, and 14 is the number of the group. Let's try it one more time, okay? Let's say I have an atom which is X and the number is coming as 8. Give it a try, guys. 1s2, 2s2, 2p, 4. Now tell me, what is gonna be the period again? Period is the shell, outermost shell, which is gonna be 2. Second period element. What is the group now? It's a P block element, right? P block, it is very evident. I don't have to do that. P block means always you need to add 10 with it. So 10 plus what? See, again, the number of electrons present in the shell is 6. So group 16 is where I'm gonna find it. Now you try one question. Let's say X is an atom with the atomic number is 10. Can you pause the video and can you just try it? What is the position of this element? Now if you have tried this, you should be able to find 1s2, 2s2, 2p6 as the electronic configuration. Again, it came out to be a P block element. That's the first thing to find out. Now for P block element, what is the period? Again, the period will be 2 again, second period. And period means this, right? In this way of the periodic table, period. Now which group? Like this way, which group? In the horizontal manner. So for the group, what you have to do is, again, in the total shell, how many electrons are there? 8. So 10 plus 8 is 18. So it is in the group 18. That's how we can find out the position of an element for S block and P block. Okay, let's try for D block. For D block, let's say iron 26. The atomic number goes like xenon's atomic number. What is the electronic configuration? You can draw it completely. 4s2, 3d6. This is the total D block element electronic configuration for iron. Now, what is the period over here? Period is again the highest energy shell, which is 4 here. Don't go for 3 because 4 is higher. So you have to go for a higher number of energy shell. So 4 is the higher. Now, which block element is it? You can clearly see that this is a D block element. Now, how do you find out the group again here? So now again, in D block element, I told you both 4s and 3d act like valence shell, correct? In F block element, all three of them, S, D and F. All three of them acts like a valence shell. Here, the valence shell is both combined together. So 2 plus 6 is 8. Now here nothing, no such addition or something. Whatever the number comes out, that is the group number. So it is in group number 8. Iron. So if you just open the periodic table, you will be able to find iron in group number 8 and period number 4. That is where you are going to find it. So this is the method of finding out an element from the periodic table. I'm going to keep this video up to this, and I'm going to record myself one more time. From there, we are going to continue about the radius and the rest of the part of the chapter. Okay. So that will be it for today, guys. Just watch this recording and make sure you have taken notes, and also try out some questions of this, okay, of this type, finding out an element. So randomly, you can take an elements from the periodic table, write down in electronic configuration, and see that whether you can clearly find out the position of the element or not. So take an arbitrary number and then you match it with the periodic table if you can. All right. So this is the way we need to find out the elements, and in the next class we'll be actually going for the different types of radius and all the trends which are out there. Okay. All right, guys. So that's my time for today. Yeah.